Alright, building on prior knowledge. Over the last few weeks, we talked about multiplying whole numbers. We took numbers like 15 multiplied by 25, and we used standard algorithm and area model to represent both of those. So just as a refresher, redo the standard algorithm. 5 times 5 is 25. Regroup the 2. 5 times 1 is 5, plus 2 is 7. Put your 0 in for your placeholder. 2 times 5 is 10. Regroup. 2 times 1 is 2, plus 1 more is 3. Come down, add them. You have 5, 7, 3. On the area model, we're looking at 2 numbers for the top and 2 numbers for the bottom. So we have 10 and 5 for 15. We also have 20 and 5 for 25. When you multiply these out, fill in the squares. 20 times 5 is 100. 5 times 10 is 50. 5 times 5 is 25. Come through, add these up. So you have 200, 100, 50, 25. Come out with 5, 7, 3 for 375. Now, looking at this with decimals, we're going to do the same exact type of process. So if we take numbers that are very similar, where this time we're going to do 15 times 2 and 5 tenths rather than 25, we're going to do the exact same thing. We're going to ignore our decimal to start with. So 5 times 5 is still 25. Carry the 2. 5 times 1 is 5, plus 2 more is 7. 2 times 5 is 10. Oop, almost forgot my placeholder. Regroup the 1. 2 times 1 is 2. 1 more is 3. Then you add them. You have 5, 7, 3. Now, we also have to remember that we have one decimal place that we're working with. So we're going to come to the end, we're going to count over 1, and we're going to put our decimal in. So 15 times 2 and 5 tenths is going to be 37 and 5 tenths total. The area model is going to look very similar as well. So on top, I still have 10 and 5 for 15. And down here, I'm going to have 2 because this time I only have something in the ones place. And I have 5 in the tenths place. So I'm going to put my decimal and my 5. I'm going to multiply the same way. So 2 times 10 is 20. 2 times 5 is 10. 5 times 10 is 50. Except that we have one decimal we have to remember we have. So I'm going to come over, count one decimal place over, and put my decimal point in. And then 5 times 5 is 25. Same. I still have one decimal point that I'm working with, so I'm going to count over one place, put my decimal in. Then I'm going to add. And I'm just going to recreate and use exactly the same numbers I had. And come in and put decimal points behind my whole numbers so that everything lines up nice and neat. When I add them, I have 5 in the tenths column. I have 7 here. 2 plus 1 is 3. And looky there, 37.5. It works exactly the same with decimals as it does with whole numbers, as long as you remember to account for your decimal places. Now, if we want to check this using the inverse operation, we're going to take our our product, and make it a dividend, and we're going to divide it by one of our numbers that we multiplied, and we should come out with the other. So in this case, I have a whole number out front, and I have a decimal inside the division house. I'm going to bring my decimal point to the top automatically. That way I can kind of ignore it going forward. Then I'm going to come back and I'm going to look. How many times is 15 going to fit into 37? I'm going to realize that it's 2, and 2 times 15 is 30. I subtract, I have 7 left over. I bring down my help, which is a 5, so now I'm looking at 75. I do not bring the decimal down with me. We moved it up to the top at the very beginning so that we could ignore it. Well, 15 is going to fit into 75 5 times. 5 times 5 is 25. Carry the 2. 5 times 1 is 5, plus 2 more is 75. I have nothing left over. Oh, looky there. I came out with 2.5 as my quotient, which matches up to one of the numbers that I multiplied by to start with. This is how you're going to do basic division with decimals. The bigger the numbers, it's the exact same process. Just make sure that you're always accounting for however many decimals you're either multiplying by or making sure that in division you move it to the top to start with so that you can ignore it.